Okay, in previous chapters when we learned quadratic functions, right, we learned how to graph quadratic functions. When we learned cube functions, we learned how to graph the cube functions, right? So this is going to be no different. Now we're doing cube root and square root functions. We're just going to focus on those two. We're not going to learn how to graph fourth root and fifth root and sixth root, but we're going to talk about square root and cube root functions, okay? So let's just first graph this is called the parent function. The most basic of the function is the square root of x. Okay, this is called the square root function. Okay, so the easiest way to graph this is to just do a quick table of values. Okay, and when I choose a table of values, remember you can choose any value for x, any value for y. There's no right way to pick your numbers. If you pick your numbers and you do the math correctly, you're going to get exactly the same graph as anyone who chooses different numbers. Okay, so don't stress about I don't know which numbers to put in for x, because it doesn't matter. But what I might do, because I recognize that x is under the radical, so x is the square root. So I might use perfect squares. That will make my math so much easier, because I can choose whatever I want. If I don't use perfect squares, if I made x 2, now I've got to figure out what the square root of 2 is. I'm going to be using a calculator, and then I'm going to be guessing on my graph on exactly where it is. If I just use perfect squares, is 1 a perfect square?
No. Yes.
Yes. So if I make x 1, the square root of 1, don't do this to me again. Square root of 1 is 1. What's the next perfect square? 4. So if I make x 4, y is then 2. I don't know why my board is acting up lately. Next one, 9. Yep, x is 9, y is 3. Okay, can x be a negative?
Yes. No, it can't.
It can't, because it's under the radical and it's imaginary at that point. Okay, so this is enough points for me to just approximate what this graph is going to look like. So 1, 1, 4, 2, and 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. Is 0, 0 going to be on the graph?
No.
Yes.
Which one is it? No or yes?
I think it's no.
Okay, so if I plug 0 in for x, what do I get for y?
0.
So 0, 0 is on the graph. Okay, and in fact, that's the first point that can be on there. Anything less than 0 won't be on there. But 0, 0 is on the graph. Okay, so now all I need to do is connect them. And that's the graph of the square root of x. Okay, we're going to talk just a minute now on domain and range. We've talked about domain and range before. Okay, but I want to refresh you because you're going to be asked questions on web work and on my tests. Domain and range of this graph. Okay, domain, to refresh you, is all possible x values. And range is all possible y values. Okay? So tell me the domain in interval notation of this graph.
1, 4, 9.
What does domain mean?
Oh, 1.
All possible.
All possibles of x.
So what's the smallest possible x value? 0. Does it include 0?
Yes.
Yes, because 0 is on the graph. So it includes 0.
1, 4, 9.
Is there any number after that that is not included?
No, there's not. So infinity.
There you go. There's my domain of this function. Starts at 0 and goes on forever to the right. What about the range?
Wrong y values.
Uh-huh.
So we have 0.
0.
Well, we have 1, 2. But it's going to be infinity.
Mm-hmm. Because this graph is just going to get bigger and bigger and bigger to infinity. It's going to include all y values all the way up to infinity. Okay, so that's my domain and range of this function. Okay, now I'm going to show you this we call the parent function, the most basic function. The general form, just like the general form of a parabola was that. The general form of this is that. I really don't need the parentheses even. Okay, so let's think back to when we were doing parabolas. If I had a function like this, I would take my normal parabola that's at the origin and do what with it? What does this tell me to do? The -2. Do I shift it? Which direction?
To the left.
You think it's to the left, but it's not. Remember, it's opposite of what you think on the x direction. It's 2 units to the right. And then the 1 unit up. And the 3 tells me the slope is going to be steeper, right? So it's going to stretch that graph up. Okay, if it's greater than 1, it stretches it up. If it's less than 1, it pushes it down. Okay, these rules that we learned with quadratics are the exact same on any function that you have, including square root functions. The a will tell me how fast, if the a is bigger than 1 or less than 1, it's going to have that impact on the graph. Okay, if h is positive, that means it's going to be x minus h, which means it shifts right. If h is positive, here h is 2, which is a positive number.
Shifting to the right.
It shifts to the right because the general form has that negative in it. If h is negative, it shifts to the left because it's going to turn that to plus. And then this number always shifts in whatever sign it is. Okay? So if I take this general form and I want to, let's do this. And I want to figure out what this does to this general form. It's going to take every x value and shift it left 1. So this goes here, 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 here. Shifted left 1 because it's plus 1. It shifts every point down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay? And then that 2 means whatever my y value is, it's going to be magnified by a factor of 2. Okay? So 2, I want to do that. -2 becomes -4. No, I should have done it first, I think. Multiplied each one of these by 2, and then shifted the points down. That's what we want to do. So let's start that over again. Okay, 0 times 2, 0. This one times 2 moves it up. It's at 1, moves it to 2. 2 moves it to 4. What is this one? 3 moves it, that's 3 on the y. 3 goes up to 6. Okay, so that's what it would be if I just had 2 times the square root of x.
Okay.
Now I'm going to shift each one of these left 1. I'm going to erase these as I go so I don't confuse myself. Stop. Okay, and I'm going to shift them down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And now I have the new graph from the original. And you see how it's
You want us to see what you want both to be displayed?
well, no, I'm on WebWork, it's going to ask you to pick the graph that represents this, or you're going to have to graph it yourself. So you just follow whatever directions WebWork gives you. On a quiz, I might say, given the graph y equals square root of x, graph this on the same graph. Okay, so you can. What's the domain now?
It's still all possible y x values.
Yep. So what's the lowest x value?
Negative
-1 to infinity.
to infinity.
What's the y?
And the y is -1.
-3
-3.
to infinity.
Oh,
X, y.
yeah, negative.
Okay, we good with that? All right. Now, if my board will work, I'm going to show you what the cube root of x function looks like. And I guess we're going to do it in red because I didn't change the color. Okay, so now we're going to do the parent function, x, there's a 3 there. Okay, thinking what I want to use for x values, what do you think? Perfect cubes would be the easiest.
So our first one is 1.
Okay,
Next one is 8.
8, the cube root of 8.
And then 27. That's 3.
Okay, can I have negative?
Yeah.
Yep.
Yeah, because it's okay to have a negative under the root. Okay, so if I could also do -1, and then it would be -1.
And negative 8.
-8 would be -2.
Negative 27 would be -3.
Okay, that should be enough for me to get a sketch here. 0, 0 on the graph. Yes. So it goes through the origin. 1, 1,
Yes.
-1, -1. 8, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2,
And negative 8.
1, 2, 3, 4, 5, 6, 7, 8, down 2. Okay, I'm not even going to do 27, but you can kind of see. I'm going to just connect these, and then it's going to continue growing slowly. It's interesting because the cube root function, or the cube function, looks like that. The cube root function just turned 90 degrees. Turned, well,
It's turned whatever.
yeah, whatever it is. Okay. What's the domain here?
All possible x values.
All real numbers. What's the range?
All real
All real numbers. So I don't have any restrictions on the cube root function. I have restrictions on the square root because I can't have negatives under that radical. But I don't have any restrictions. Yep, all real, all real. That's your domain and range. Now, this is our same thing. Okay, so
It has a cube.
yep,
Where'd you get the -1?
I'm making this up so I can show you the transformation. Okay, what does the negative mean in our quadratics and the parabolas? What did it do? What did the negative mean?
Push it down.
Flipped it over the x-axis. Okay, so if I apply a -1, I don't have to stretch it any because it's 1, but I do have to flip it. So now every point is going to be on the opposite side. And where was this one? Okay, so that's my first, just handling the -1. Then I add 1 to it, right? So I'm going to move it over 1 to the right. Get rid of those. Okay, and now I'm going to shift all the points up 2. 1, 2, 1, 2, 1, 2, and 1, 2.
So those are just random numbers that they will give you, that you give us, so that
What are random? This is a random function they're going to give you.
are they going to give us the numbers, or we have to find the numbers of the function?
They should give them to you.
Okay.
And then you're going to have to use your knowledge of what that transforms the function into.
Right.
The negative flips it,
I
the
just
1
didn't know
or
if
the
they
2
would
will
give us the
stretch.
-1, -1, and 2.
Yeah, they aren't going to make you make them up. Yeah, because you can't graph it if they don't give them to you. But did you see how it flipped? It shifted right and up 2. Okay? The more practice you get, the better you'll get at it. But let's look at our textbook check real quick. Okay, first question. This is the graph of which function? Y equals the square root of x. Y equals the square root of x, okay? And here, maybe. To graph this function, you would start with the parent graph, y equals the square root of x, and you would shift it right 2 up 5.
Up 5.
Right, 2 up 5. Question 3, what's the domain of this function? Negative bracket, -1 to infinity.
Y bracket.
Why? Because that point is on the function. It's closed. Bracket means it includes, and when you close a circle, that means it includes. If the circle is open, that's the same as a parenthesis. Good question. Question 4. In this function, 1/2 times the cube root of x minus 4, what does the 1/2 tell us?
1/2.
It grows slower. Grows slower. Yep. And in question 5, the domain and range of all cube root functions is negative infinity to infinity. True. True. There's no restriction there. Okay. 7.3 is open on WebWork. You won't have a new section until Wednesday next week because we have review for the quiz Monday and the quiz Tuesday.
When is that game? What day are you doing that?
Oh, I have to pass those out. We'll probably maybe start doing them on Fridays or something, just for fun. We might even do a couple just quick ones, like 5-minute long, just a couple at a time, and then do a formal one sometime coming up. I even thought about doing a game with guessing the functions. Like if I give you a graph of a parabola, you have to say y equals x squared. If I give you a graph of something that starts at 0 and goes forever, y equals square root of x. You know, something like that. What's that?